Hello, and welcome back to the video lecture series for Introduction to the Art of Programming using Scala. We're continuing on with our look at abstraction and polymorphism, and in this video we're going to talk about inheritance and inclusion polymorphism. So inheritance is a very common feature in many class-based object-oriented languages, and it's one of the primary ways in which we get polymorphism. In this case we specifically get what's called inclusion polymorphism, which is a form of universal polymorphism. So it gives us the ability to write one piece of code and have it work with effectively an infinite number of types. Now to illustrate this, I'm going to start off with a very simple, straightforward example to go through some of the features of inheritance and inclusion polymorphism. And I'll start off working in a UML diagram. Let's see. UML, I don't care about shapes. Load. And let's go to a class diagram. There we go. Okay. So the idea here is I want to create a type that represents a shape, and it's going to have a lot of subtypes, and really it's the subtypes that gives us the power of polymorphism. So I'm going to take and make a class over here, and I'm going to call it shape. Now, depending upon what type of application you're writing, there are lots of different things that you could put inside of a shape. I'm not going to put any data in here for now. Maybe we could see how, actually, it's an interesting question. Yeah, for now I'm going to start without anything there. We could add a color or something later, if assuming these were shapes were going to be drawn. I'm not going to particularly go down that that line or that approach. Okay, actually that's fine, let's do it. I'm managing to convince myself in my head that we should have a color for all shapes, and in addition they are going to have the things that I wanted to put in were methods to calculate an area and to calculate a perimeter. Both of those return doubles. And you know what? I also want a method that draws a shape to a graphics 2D object. Okay, so there is our shape supertype, and these, whoops, not public, private. We'll come back to that. Okay, so we have a shape here, and what this is basically saying is that every shape needs to have an area, it needs to have a perimeter, and it needs to know how to draw itself, and it stores a color. Now, what types of subtypes could we have of shape? There are lots of different things that are shapes. I'm going to start off with two very simple ones in here. The first one that I want to make is a rectangle. And what information does a rectangle store? Well, a simple implementation would be a width and a height. Okay. And the other one that I want is a circle, and a circle stores a radius. And now I need to indicate that these inherit from shape. So in the UML diagram, I draw a connection, and I believe this is the order that I do, and it should be an extends arrow. Yes, good, that is exactly what I wanted. So I have an extends arrow between rectangle and shape and between circle and shape, and you'll notice the extends area. So if you're writing this on a whiteboard, what really matters is there's a connector and it has this open arrowhead. That is the indication in UML that this is doing inheritance, the extends relationship. Now, what does this mean when I draw this in the diagram? you'll notice that I haven't duplicated any of the things from up here down in here. That is because by default, everything that is up in here is implicitly copied down. In fact, this is kind of the place where the term inheritance comes from, because that's what inheritance means in the human sense, is that when you inherit, you get something from your parent or someone else who's above you in your family tree. So that's kind of where the name came from, and that's what people were originally thinking of when they created this concept of inheritance. So I don't have to put an area down here, because if I call area on a rectangle, by default it's going to use the one in shape. And we'll see there's nuance to that in just a bit, but this diagram in theory works because of the fact that both circle and rectangle get all of these things from the shape. In addition to getting all of those features from shape, they also become subtypes of shape. And what that means is that if I write code that takes a shape, it will work just as well with a rectangle or with a circle. And the reason why inclusion polymorphism is considered universal is that then I could create a triangle, and I could create an octagon, and I can just keep creating new subtypes of shape. So in essence, there are an infinite number of subtypes that I could create, and they would all work with my one piece of code that deals with just a shape, because they are subtypes. Okay, so that's really what we're going for here. So this is what this looks like in UML. I want to briefly write up the code that would do this in Eclipse. So we'll bring up Eclipse. I'm actually going to add a different little package in here. I'm just going to call it little examples. Package names are supposed to be all lowercase. We'll be putting things in here occasionally, so putting things in the default package is discouraged, and it can cause name conflicts, and it's hard to disambiguate the default package. So I'm going to put this inside of its alternate little package. And inside of little examples now, I am going to create a new Scala class. Sorry, these menus are going off of your screen. I went to new Scala class. And the first one is going to be our shape. And it'll pull that up. And things that I had in the shape. So I had a private val called color, which is a color. And it won't. What should I start this off as? Actually, if it's a private val and it's being, and I should do this. Private val color is a color. Otherwise, I have to give it a value down here, and if I give it a value, then all shapes have the same value for it if I give it in there, whereas if I make it so you can pass it in, that will work better. It wants to import color, so I'll hit Control Shift and O, and I'll let Eclipse do that work for me. And then I had a number of methods. So let's go look. I want to have an area, a perimeter, and a draw. So def area returns a double. Def perimeter returns a double. And def draw takes a graphics 2D and returns unit. Control Shift O again. Okay. This has an error which we'll fix here in just a second. Or at least we'll get rid of this error. Maybe not in the ideal way. We'll come back and revisit that probably in the next video. So the problem that we have right now is I have an area, I have a perimeter, I have a draw. What should they do? Well, what is the area of a shape? This is problematic because shape is so very broad as a classification. I don't know how to calculate its area. And we'll come back and we'll look at the proper ways to do this. Right now, I don't have a good way to do this. So I'm going to just have it so the area by default is 0 and the perimeter by default is 0, and the draw does nothing. Okay. And now the shape is happy. I might not be happy as a developer in certain ways, but at least the shape code is happy. And then I could finish implementing the things that are, so I'm going to go up to New, Scala class, make myself a little rectangle. Now I want to be able to say that this rectangle, actually let's see this first, val width is a double, val height is a double. I'm willing to make these public as long as they are immutable for now. If we were to have them being mutable, I would not be willing to make them public. I would make sure that they were private. And the rectangle is supposed to extend shape. Now the shape wants an argument here because, in fact you can see this error message, not enough arguments for shape. Remember, we were supposed to give the shape a color. I will say that actually, let's do this. I like that. That is more flexible. And if I hit Control-Shift-O to import, so what this says is that the rectangle takes a width, a height, and a color. It passes this color on up to shape. Just a formatting thing. Many people who do Scala coding, if the argument list starts to get long, they will do that and put every argument on a separate line, especially because many of them are vals and vars, and they're effectively associated with the class as opposed to being just a straight argument passed in. If we go back to our UML, right now this is all that we have inside of rectangle, and this is currently happy. Let's go ahead and let's create our circle class as well. So I'm doing New, Scala class, circle, and I want to do the same type of thing here. Val radius is a double, C is a color, extends shape of C. And save. This code is happy in the sense that it compiles. However, you can quite possibly already see some problems, which if I were to use this, right now all of my rectangles and all of my circles, regardless of their radius, width, or height, all use this implementation of area, and therefore everything has an area of 0. That is a problem that we need to fix, and we will come back and fix that in the next video.